Welcome back to this information system course. The objective of this class will be to introduce the topic of requirements engineering. The objective will be to provide a strategy to collect all those requirements that until now we have seen only in textual and written form. So every time we start in a process about requirements engineering, about requirements collection, we can see that we have a kind of V model that will guide all our software development activities. We can see that we start from all our development process will start from the so-called customer needs. So what my customer or my commissioner needs. After this collection of customer needs, which are just those at this level, we will perform a phase of requirements analysis. After all the requirements are analyzed, I can perform the system design in a detailed way, especially if the system is very complex. At this point, my developers can write the code and actually implement all the functions. Then we can get back in our V model and we will perform activities that are related to the first half of the V. So I will perform different types of testing to verify that all these steps have been made properly. As I go upper in my V model, I see all the aspects that are more relevant for the client, for the commissioners. So as soon as I get back, I will get back to the verification of my original customer needs. This will be done through a phase that is called acceptance testing, meaning that my customer, my client, will look at my product and will see if it is compatible with the original idea of product that he had in mind. In the middle, I have different forms of testing, like unit, integration, and system testing, that are typically made, again, on the customer side, but they are made to verify elements of the design and the implementation at the lower level of my system. In this course, we will be limited to the aspects and to the needs of the customer. So we will stop at this requirements analysis phase, and all the rest, which is software design, basically software coding and software testing, will be of little interest to us. Anyway, it is important to stress that the requirements analysis phase is a fairly relevant phase in the whole software development model. In general, and those images that you will see are something that can lead to disasters. And in these slides, I will show some images that are pretty old and typically used to show the reality in software development, because typically I, as a user, I, as a developer, have something that is asked by the users with their language. But the problem is that in my company, I have some analysts that interpret these idea of the users in a different way. Then in the design, I can try to find some solutions, but I still going farther away from the original description of my client, of my customer. Then the design may be, when it is translated in the implementation by the developer, it is again different from what was told. Then at the end, the system, in some way, with some trick and some fixes, will be made to work in some way, but actually not in the way that was taught. And basically the issue is that at the very beginning, maybe the user asked for something, I interpreted something, but the user really wanted something else. So the objective as a requirements analyst is to try to keep every phase in the middle as close as possible to the true idea of the customer, and without deviating so much during all the steps of software development. So we get to the so-called requirements engineering. Requirements engineering is the set of processes and techniques to understand the needs of the customers, to pose some constraints on the system that I have to develop, so that I can develop it in the proper way. The requirements will be themselves a description of the system and a set of different constraints that I have to pose on the system, and all of them will be very relevant during the design and implementation phases of my system. The activities in requirements engineering will be substantially four, and we see that we have a first phase, which is called elicitation, which is a nicer way to say collection of requirements. It is related to the Latin word, which means extraction. And we will have a phase of requirements analysis after the elicitation to say, okay, these requirements looks fine or not. We will have a phase of formalization, which means writing down the requirements in a proper formal document. And finally, we will have a phase of verification and validation, which will be performed after developing the software to verify that the requirements were implemented properly. But we can start from the elicitation. So, as I said, it comes from the elicere verb in Latin, and it is a kind of nice word to say that I am extracting stuff from people, from the customers, from the committants with which I am talking. In general, I extract information from the stakeholders, so from all the people that can give us some information. So I'm kind of drawing out the people with which I can talk. I talk as much as possible with people that has an interest in the development process, so that I can grab all the possible information to understand the needs of the system in the best way possible, and so to describe in the best way possible the system that I have to develop. I can use many different techniques to perform requirements elicitations. The most common are brainstorming, the analysis of documents, so analysis of documents that describe what my system will do. I can use the so-called focus groups. Focus groups are kind of calls or anyway meetings where I have people that are asked precisely on some aspect of my system that will give us opinions, their ideas. Or maybe I can use the so-called interface analysis, so I can find some already existing interface, and I can analyze it to understand what features I want to implement in my system. I can also perform interviews with potential users of the system, or I can ask something to people who have need that I have to solve in my system. I can analyze this and observe the way people is working, performing the so-called job shadowing activities. So I sit side by side with someone using a system similar to the one that I want to implement, and I kind of spy what he is doing. I can sketch up prototypes and get back feedback from who uses those prototypes. I can perform workshops, so I can collect people with the same ideas together and put people together to write down the requirements and collect all the ideas. I can, if I want the opinions of many people, I can use surveys and questionnaires, so I can create a a web questionnaire in the simplest form, a Google form, and I send it to hundreds of people so that I can find the ideas and the requirements and the needs of many different stakeholders. So that my elicitation has also a statistical relevance. In general, what I have to keep in mind is this concept of stakeholder. So the stakeholder will be any kind of party, any kind of role, any kind of person that has an interest in the system or is concerned or is influenced by the system. So the stakeholder will of course include the user of the system. So if I am the developer, the requirements analysis of Spotify, of course I have to keep in mind what are the users, the final users, because the requirements will be targeted towards the final users. I want to have a nice application which is easy to use. But of course, I also need to keep in mind the procurer of the system development, so who commissioned the development. Typically, when I develop something, I have some person interested in making money out of what I am developing, or making profit, or gaining advantages from that. So I have to take into consideration the commitment of the system. Also, there are other people, in addition to users and committants, who are influenced by the use of the system, because our systems won't live in a bubble, and they will interfere with other people. They will have influence on other systems. I must consider, so in many cases, also ethical aspects, social aspects. For instance, if you think of a video surveillance system, the user will be, for instance, the operator which collects the data. So the guy that goes to the web application to look at all the videos. The committant will be maybe the bank which commissioned the video surveillance system. But there are people that are influenced by this system that are neither the user nor the committant, because if with a video surveillance system I will have many people who get their faces recorded, and maybe they don't want to, so they have an interest in the system because their videos, there will be pictures and videos of their faces, and this will clearly influence their privacy. So it is necessary to take into account all the possible people that may get influenced by a system that I am developing. Requirements must be distinguished by the design, because requirements and design are different aspects of the software process. Basically, I can divide requirements and design by two who works, and the requirement will tell me what the system should do. The design will tell me how the system is done. It is important to separate these aspects, because if we put in the requirements even aspects about the structure of the system, about how the system is done, which are not related to the initial ideas and constraints of the commissioner, of the customer, those constraints will influence the final design, the final development phases of my project, and they might be too strict, and they might render the development impossible or very difficult. So actually in the design I will add all the details about what technologies, what methodologies I am using. In the requirements analysis I only think about what is my original idea, what is my objective, and what are the features at high level, at an abstract level, that I will need to implement. I don't care about the how. So it is important to define what a requirement actually is. A requirement can be many different things. So a requirement can be a single sentence, a description, a very abstract description of a system or service, it can also go down to be something very specific that can be, for instance, described by a mathematical formula. The requirements can also have different roles, so they can be used as a starting point for a contract, so I may write down the requirements so that I know how much money my requirement will need to implement the system, or it can be the contract itself. So it can also be a very precise specification that will guide my development. It will be written in the contract that my developer will exactly do the system in that way. There are two types of requirements. I may have user requirements and system requirements. User requirements are those related to what the system will provide to the users, and typically they are written in natural language, so how I speak normally, plus diagrams. They allow to understand the users and the commissioners to decide if that system is the right one for them. System requirements are instead used as a starting point to perform the real design, and they will define a lot of details that are useful to implement and code actually the system. Typically inside the requirements document I will have a part for the user requirements and a part for the system requirements, because they are two fundamental different levels of details for the same concepts. And as we can see, one example of a user requirement might be that the software must provide a way of accessing external files, like I want a connection with Google Docs. And this user requirement is the only thing that I care of as a user of the system. I just say, I need a way to access my files. Instead, these requirements translate to a lot of details that are needed by the poor people that has to implement the system. So I get to the system requirements related to the user requirement, and I see that I have a lot more detailed requirements where I say that the specification about what the user can do with the system and what are the operations that they can perform on external files. In general, I have two types of requirements, we said, and different people interested in them. I have the user requirements who are typically read by managers of the client, final customers, final client, end users, engineers of the client that will use the system, and possibly also system architects who want a high-level view on the system. System requirements will be read only by the developers of the system architects, and by the final users if they want to have a detailed analysis of the system, of what the system does. So we have different typologies of users for each requirement, and of course we will have, after the requirements phase, we will have also the design, which came after in the V model of development, which is an additional refinement of requirements that will express details of about how the system works, about how it is done, and this will be read by developers, by software architects, and by client engineers, so people that have technical skills and that can see in detail how to implement a system. As everything that can be that is made by a human, the requirements can be made in a good way or in a bad way. There are many different features that can be used to evaluate if requirements are good or not. First of all, correctness. I will have a document and with all my requirements, and each requirement will need to describe a characteristic that the information system must implement. So the commissioner, the clients of my information system can actually decide if a requirement is correct, if it actually represents something that is needed or not. So if the requirements represent something useless that does not reflect any actual need, it will be incorrect. Also important is that requirements must be unambiguous. So in the limit of the possible, requirements must have a single interpretation. The idea is that each characteristic, each feature of the system must be described with a single term to reduce all the possible ambiguities. Requirements must be read by different actors, by different people, we have seen that, and all the people should, typically won't be like that, but should be able to read and interpret the requirements with the same meaning. So I have to be clear in the requirements solicitation and the requirements specification I need to be careful to define the terms that may not be so obvious to reduce ambiguities between different requirements in my document. As well, requirements must be complete. So if I have a complex situation that I want to serve with an information system, I need to make the requirements contain all the necessary information. And I need to make reference to all the needs and all the constraints of the stakeholders. So typically, when I have requirements for a software system, typically there will be some input part in the system. There will be an interface or whatever, and I will be able to write down or to provide input to the system. In this case, I will contemplate, I will define all the possible inputs, and I will create a requirement on what I expect from that input, what type of output I expect. Of course, in general, my requirements will be complete if I have a precise definition, all the terms, all the unit of measurements, and so on. Otherwise, I can introduce also ambiguities because I don't cover a corner case in my requirements, so what happens in that case, I don't know. What is important is also that the requirements must be internally consistent, so they must be coherent one with each other. I mustn't have requirements that are kind of contradicting or fighting each other or conflicting one with the other. I, of course, need to take into consideration all the implications for all the requirements. So I need to take care if something invalidates something else, or if I have timing relationships between the requirement. If I need that something is performed before something else without contradicting it, and so on. Of course, again, to reduce the ambiguity, I have to avoid to using different terms for the same stuff. Typically, what happens is that I try to have complete requirements and I try to have consistent requirements. And these two aspects typically fight each other because they are difficult to conciliate. The idea is that complete requirements include all the aspects of the system. Consistent requirements don't have contradictions. So if I have a very system complex and I start writing hundreds of requirements, hundreds of pages of requirements, it is easier to create inconsistencies because maybe requirement in page 67 will be conflicting with the requirement in page 2 that I wrote down days before. So it is very difficult to have a description of the system which is at the same time perfectly complete and perfectly consistent. Typically, I will try to find a trade-off which is reasonable. So something that will allow me to develop the information system without errors, but without being a maniac of completeness or a maniac of consistency. Requirements are Also, something that will reflect itself in the use of my system, and as you of course know, not everything in the utilization of a system has the same importance. And again, we also need to find a trade-off between completeness and consistency. I also need to give a priority to my requirements. So typically I can provide a ranking for my requirements. They can be ranked by their values from the point of view of who is commissioning the system. So higher level requirements in terms of value brings more money, to say it easy. For instance, the payment system in my Ticket One website will be ranked very high, because without that one I cannot grab any money from music enthusiasts. The possibility of changing the user interface from white to black is actually useless, so it will be very low if I have that requirement. On the other hand, I can also put requirements in terms of necessity, so I can say that I have essential requirements, they must be implemented. Then I have conditional requirements, it's better that they are implemented. Or I can have optional requirements, so do whatever you want, developer. Last criterion with which I can rank the requirements is the stability. So maybe I can have requirements that will stay the same forever, or other ones that will be likely modified. So maybe it is a need that I have today, but maybe tomorrow it will be not stressed. Like maybe if you have the need for electronic receipts, that for now I need it, maybe tomorrow with what's happening, maybe I won't need any electronic receipts at any time or whatever. So maybe if I have requirements that may change in the future, I might rank them lower, so that the developer will put more focus on what is stable and what will remain the same. What is the issue about requirements? The issue is that I have some constraint, so I need to have the possibility of verifying my requirements. So when another quality of my requirements will be the possibility of verifying them. So there must be some way, some algorithm possible, that will allow us to check in a limited time if a requirement has been implemented or not. Of course, the verifiability of requirements is related to their ambiguity, because if I have ambiguous requirement, I don't even know what I've written on paper, and it is difficult to evaluate them if I don't even understand them. I can have even different opinions between the commissioner who wrote the requirements and the analyst and the developer who implemented the requirements. So it is important that requirements are complete and unambiguous, so that I can have objective verifiability. To put it in another word, if I am the client, if I am the commissioner, if I am the requirement analyst, and I write down precise requirement, then if the software is different from what I expected, and my requirements were good, the developer is screwed. Otherwise, if I wrote down bad requirements, ambiguous requirements, and the software system is not what I expected, the developer can get back to me and tell me, hey, but your requirements were terrible, and so I had to make assumptions about them. So the verifiability is paired with ambiguity of the requirements, because only unambiguous requirements can be verified properly. The requirements can also be modifiable, so there is another property which is the modifiability of requirements. Actually, when you are writing down requirements, you are not carving in stone the 10 commandments, because as we said, there is the possibility of having different needs evolving over time. So again, I am writing down the requirements for an ATM, and maybe tomorrow I will sketch down the requirement about giving the possibility of collecting 10,000 euros in cash, but maybe in 1 month from now I will write down the possibility of getting from an ATM 1 million euros in cash. So the requirements always change according to whatever happens, and so it will be needed the possibility of changing the requirements. Of course, to change the requirement, I will have to have requirements document who are easily readable and structured, so that I can find what are the aspects that I need to modify. If my cash limit is, I know that it is in a specific section in page 13, maybe, it is easy that I can change that aspect from today to next iteration, next development of my system, and so on. Last aspect that we need to take into consideration is the traceability of requirements. So the requirements must be, I need to know who is guilty for a requirement, who is responsible for a requirement. So I need to understand what is the origin of a requirement, and I need to be able to follow the path, the process, the development process that we have seen in the very beginning, the V model. I need to find why the hell I developed some specific features, so that I don't get blamed for those features or for those design. I need to be able to get back to the requirements. As well, from the requirements, if I have my requirement document, I need to have forward traceability. So starting from the requirements, I need to have a mean, to have some possibility of understanding where they are not in my code. So the idea is that I start from the requirements, then I have my design, and then I have my code, which is made by my poor developers. And what I have to find is a kind of traceability between the requirements to the code. I need to understand what requirement correspond to a software function, to a code function, and vice versa, so that the right people can be blamed if something goes wrong. Basically, we have seen many different properties or quality aspects of requirements. If we kind of reverse them, we can see all the possible defects in requirements. So rapidly, we can see that we can have inconsistencies like contradictions or omissions, so something missing, or ambiguity, of course, or simply incorrect facts. Maybe I just write down something that it is not asked from my commissioner. I can also have over-specification, which goes again in terms of completeness versus consistency, meaning that I try to put too much stuff in the requirements that will be impossible to cope with these requirements. So at some point I have to stop in the process of providing details in my requirements. Or maybe I have unstructured requirements that will make it very difficult to find where my requirements are if I want to modify them. Or maybe I can have redundancy, so maybe I have 100 requirements all saying the same thing. So we have seen until now what is a requirement, what are the properties of a requirement, and what are the possible defects in requirement. We also have two different types of requirements, main types of requirements. Those main types of requirements are functional requirements that will define the characteristics, the features of my information system in terms of what it does from a pure development style, correspondency between input with an output. So I have a certain input in my system, and I will have a certain output from my system. On the other side, I have non-functional requirements that are also called quality requirements. Non-functional requirements are related to a set of different constraints, not about what the system must do, but about how well the system must behave. So they can be temporal requirements, requirements about the development process, standards, usability, and so on. I lied because I said that there are two categories, but sometimes a subset of non-functional requirements are separated in domain requirements, and they are requirement constraints related to the specific domain, to the specific context where I will have implement, where I will provide my information system. We talked before about video surveillance systems. In that case, I have a system in a domain which is sensible from the privacy standpoint. So I will have other requirements related to that privacy stuff. It is useful to define non-functional requirements. So, as we said, they all define system properties and constraints that are related to how well to the quality of my software system. We have some definitions about types of non-functional requirements. The best way to visualize them is to look at a kind of hierarchical representation and a kind of taxonomy of non-functional requirements. We have three different types of non-functional requirements in our mind map. So we can have product aspects, product requirements that are related to the product that I am creating. So I can talk about the efficiency of the product, the reliability of the product, the usability, so how easy it is to use it, and the portability. So maybe I have to use the same application on both Android and iOS. That becomes portability. How easy it is to use the same system in multiple places. I can have organizational requirements. They are related to how I serve my product to my customers. So I can talk about delivery, I can talk about standards that I have to respect. Maybe if I am developing critical systems for airplanes, I need to follow a specific process to guarantee that at the very end my system is safe. I can also have external requirements like interoperability requirements. My system must work with Google Maps, so I will work with the API of Google. I can also have ethical requirements like the video surveillance of before, or the GDPR, the management of all the sensible data. Or I can also have legislative requirements. So like for now, we have to provide digital receipts for every kind of online sale, but in the future, whatever. All those aspects are non-functional, because you say here, we are not saying what the system is doing. Here, I don't know if I am talking about a ticket management system, a web surveillance system, or an online store or whatever. But I focus on how well it will work. So how usable it is, how efficient it is, how reliable it is, and so on and so forth. In general, we can see another chart here because the non-functional requirements talk about aspects that can be called altogether software qualities. And again, here, with these four bubbles, we can see what are all the qualities of the software. And typically, I can have qualities that are related to the process. So what specific way I use to implement my system. So typically there are process models that lead the way I develop the software with a set of specific practices. Then I can also have more specific aspects of the system, like internal quality, which I can evaluate immediately on the system, like how good I implemented the system with my Java language. I can have some automated tests that verify if my system is good or not. I can have also external qualities that I can evaluate by putting the system in its environment and see how well it works. Like, for instance, the usability or the let's say the dependability of a system. I can see if it is safe, if the software is safe from the point of view of the users only after I put it in use among the users. I can also have some other aspects of quality which is related to the data that is managed by the software. So, for instance, I will have a database with all the data that is generated by the system while using it. In that case, I can have measures to understand if data that I produce, that I introduce in my system is of quality or not. Finally, I can also have quality in use, which means how I interact with my customers, with my users. Is it easy to use? Is it well integrated with other software that I can use? And so on and so forth. Again, I won't go into the detail because there are many different quality models that can lead the definition of non-functional requirement. For instance, there are ISO standard. The ISO is that organization which is kind of creating standards for everything that can be conceived by a human being. And basically they also talked, of course, of quality of software. And there are many different components in the ISO standard. So they define how to write down quality requirements, how to evaluate quality, how to manage quality, and how to measure quality, of course. And in the quality model, that is this one, we see that we have three different qualities, three different categories of qualities that are related to what we have seen before. We have product quality, where we can consider here the functional suitability, the efficiency, the compatibility with something else, so how reliable or dependable is the system, the security of the system, of course, and the maintainability, here we miss an N, which means the capacity of maintaining and providing maintenance on the software, and the portability, which we already defined. We also have the quality use, so we define quality use like how well the software behaves when I am using it, and here we have concepts like the effectiveness and the efficiency, so how good I am in doing my job, the user satisfaction, the perceived risk from my users, and the coverage of the context, so how many contexts I can cover with my software. So maybe my software works in a specific context and it is completely useless in all the others. Maybe with my Ticket One website I can only sell tickets in Italy and not outside. So how many contexts I can cover with my system when I vary some properties of where I am using the system or how I am using the system. Then there is a bunch of data quality properties, like the understandability of the data, the credibility, and blah blah blah, and so on and so forth. Of course, you don't need to know all the qualities and details, but it is important to know what are the principal requirements, non-functional requirements. So to wrap it up, we can have non-functional requirements that can be divided in three categories: about the product, about the organization, and about what is outside, so external requirements. Among the product requirements, I can look at my ISO quality model, and I can see all these infinite lists of categories of non-functional requirements and qualities of my system. The last part of this lesson will be related to how we want to represent the requirements, and specifically we will get to the requirements document. So it is important to represent the requirements in a specific way. In the case of non-functional requirement, it can be very difficult to write down what I want precisely, because non-functional requirements, as we have seen, are like of 1 billion different categories. So when I want to specify non-functional requirement, I need to write down them in a precise way, so that I can write them down properly and understand them. And one option is to separate the non-functional requirements into two separate aspects: the goal, so the intention which is behind the non-functional requirement, and a measure. The measure will be a requirement, some metric that will allow me to see, to quantify if that requirement has been implemented or not. So I have on one side the goal, which is a higher level requirement that can help me interpret what are my lower level requirements, my smaller requirements. On the other hand, I have some measures that can be verified, that can be specifically and objectively tested. An example might be that I have a high level objective, like the system should be easy to use by some people and should be organized in a way that the user errors are minimized. So in my idea, I am the commissioner of a system, and I go to my developers and I say, okay, this must be easy to use, period. How do I verify that a system is easy to use? It's not trivial. So I can move from the goal to a verifiable and traceable non-functional requirement, and I can say that my system is easy if my experienced controllers can use the system, can be able to learn the system in 2 hours. So you see that we are introducing a different layer here. Before, I say just my goal, which is it must be easy. Then now I put a number on that easiness. I say that my system is easy if it can be used in 2 hours. If after 2 hours I'm able to do everything with my system. If my training must last at most 2 hours. This is an important, a crucial step, because if I put numbers to my requirements, then I can measure these numbers in reality, and I can blame my developers if they are not reached. There are many different measures that can be used for non-functional requirements. You have just some examples here, but for instance, if I think of reliability, so how dependable is my system, I can measure the rate of failure occurrence, so how many errors I can have. Or if I think of portability, I can say how many target systems I need. So maybe I am developing a browser application and I say, like, I want it to work with 4 different web browsers. And so my developer will make it compatible with Opera, with I don't know, Chromium for Linux, Firefox, and whatever. So basically, I define some measures, and there are many of them, and of course we won't see all of them, and you don't need to memorize all of them. There are many different measures for each of the non-functional requirements for each of the software quality that is defined by the ISO standard. What is an issue when describing requirements with natural language? The issue is that I write down my requirements document, which will include my functional and non-functional requirement, and I write them down all in natural language. The issue with natural language, with literature language, is that it might be imprecise or unclear for who is reading the requirements document. So we can get to the issue that we had in the very beginning, where I wanted a very specific object, and after all the phases of the process of developing software, it became something completely different. So with natural language, I can have the so-called requirements confusion. If I use sentences that are not structured well, I can mix in the same requirement functional and non-functional aspects, with the result of making a mess where I have features, input, outputs, and constraints, numeric constraints in the same requirement. I can also create the so-called requirements amalgamation. So I put all the different requirements all together in a whole paragraph of text, which will be very difficult to districate, to interpret in a reasonable way. So all of this led to our final artifact. So we have seen until now what are functional requirements, what are non-functional requirements, and what are the ways, the things that you have to keep into consideration while writing them down in natural language, but with some, attention. The final result will be the so-called requirements document. In the requirements document, I will write down all the relevant aspects, mined with my requirement solicitation, and there I will define user and system requirements, functional and non-functional requirements. There are some standards, this time not by ISO but by IEEE, and there is a trace for the requirements document structure that has been defined a long time ago. Actually, there is a more complex one from 2011. But basically, I will have a preface where I just say, hey, these are my requirements about this system. Then I have an introduction, again, by describing this will be a requirement document and blah, blah, blah. Then I have a glossary where I specify all the terms that I will use to reduce ambiguity. Then I will define the user requirements, so everything that we have seen until now. Then I will define the high-level system architecture and the system requirements specification. Then I can have other aspects like models of the system, like more process models, information models that we have already seen in this course, and that will be put in the requirements document. So the concept, the class diagram and the BPMN diagram will be in this phase where we have system models. I can have a description of the evolution of the system, a kind of guideline about the aspects I will put more attention on, and then I can have whatever, other aspects like indices and whatever. Of course, this is a very important document and it is kind of weighty, a heavy document. There is another way, which is the lightweight requirements document that has been defined later because it was too difficult to follow that one. and basically here I have a lower number of places. I have a purpose and scope section, and in this case I define what is the overall scope and goal, so the general context and the objective of the system that I want to implement. I say who cares about the system, so who is influenced by the system, so my stakeholders. So I have a paragraph with my stakeholders. I write down what is inside my system, inside the scope of my system, and what is outside. So I say here what I will need to develop, what I already have outside, and what I will have to develop with my developers. Then again, I have my glossary, which is simply just a list of names and explanations. Then I will have the use cases, which is the next topic, the next diagram that we will see in this course. So the main actors of the system, the user types of the system, and how they interact with the system, and the interactions at eye level. And then the use cases, which are collections of interactions to reach some user objective. Then I will have the technological aspects. So the technologies that I have to use, the technology requirements. Do I need to make it as a web application with the microservices behind, or do I can use a simple client-server architecture? So whatever technology requirement, whatever technological need that I have, I will stuff it into this section 4. Then I have other various requirements where you can stuff all the requirements that are non-functional. Development process, rules, performance, operation, security, documentation, usability, maintenance, portability, everything can go here. And finally, I can have other aspects which are not of much interest in this course. They are related to human backup. So human backup means if everything gets destroyed by some catastrophe, is there any person in my company that will serve as a human backup? So if my ATM system dies, does I have a counter in my bank where the people can grab money? So this is the example of human backup to system operation. I can have other aspects like legal aspects, and whatever impacts the organization, I will put it here. So we have seen until now, I will put an example in the course material of the requirements document. Basically, we have seen that we have user and system requirements, and another categorization, which is functional and non-functional requirements. At the very end, we will have a document after I perform a lot of interviews and talks with my committants. We will have a document at the very end where we write down all our requirements and where we create a context for my system. My requirement document will have an introduction, will have all the functional and non-functional requirement, all the user and system requirement. Then I will put there in my requirements document all the models of my system. So even the specification of the process model is itself a requirement, because it will say how my system will work. There are different guidelines that I can apply every time I perform requirements collection. So define a standard format and use it for all requirements. I am not writing a novel, so I can use a simple and standard way for writing every requirement in my system. Again, I use language in a consistent way, so I am not writing poetry, so don't use metaphors or synonyms or whatever. Just define a glossary and use the same terms for the same stuff in all the places. And again, use text highlighting, like put something in boldface or in italic, so you can have some creativity in identifying the most important parts in the requirements, because someone will read that and must have the right emphasis on the most important requirements. And again, don't use computer jargon, let's say, don't use the computer language, because as we said in the very beginning, there are many people at different levels that can read requirements, and maybe they are not developers, they don't understand computer stuff like a developer. So this was a high-level view on requirements engineering, where it happens, what it does, and why it is needed. And as we have seen, all the rest that we do in this course will be intertwined with this requirements engineering phase, or will be inside the requirements document. Thank you for watching.